Hey guys, welcome to Simply Electrical. This is my deep dive series where I take a slow and a methodical approach and go through every step and show you every code reference on how to do a multifamily dwelling service calculation. And this is a standard method. Now, if you want something a little faster, because this one is going to be pretty in-depth and I'm going to go slow through it. So if you want something a little faster, or if you just needed some examples, I have a crash course series that has just exactly that. I go through multiple examples that have different scenarios, trying to get give you an indication of what you might see on a test or maybe come across in the field. So please check the link in the description for that and other videos. I have other deep dives as well on other methods. Now, just to be clear, this is for the 2020 NEC that we'll be going over. Most everything in here will apply to previous NECs, at least the ones that are still in effect around the country. Like I think 2008, maybe even 2005. There might be some states still doing 2005. But most of these things are going to be the same. There are a few small nuances though that have changed over the different code cycles. So just be sure, if you're going with a different code, be sure to check, make sure that there aren't some changes you need to be aware of. So in the NEC 2020, we're going to be using Article 220, Sections 40, 42, 50 through 54, 56, and 60. This is a table I've developed that it's my attempt to make a very simple one-page table that will show you all the steps and everything you need to know to do a multifamily dwelling service calc with the standard method. Now I've broken it up into 4 columns, and you'll see I'll go through it really briefly right now, but don't worry if it's too fast because we're going to take it step by step incrementally throughout this video and show you everything you'll need to know. We'll start here on the left with the lighting column. And this is where you take your square footage of your building and your small appliance, circuits, laundry, everything included in your general lighting load. And you'll put that to a demand factor after you multiply it by your number of units, because this is multifamily. And then you'll get your lighting total down here. Next column is appliances. Basically, this is a per unit appliance total. And you get that here, and there are some provisions we'll talk about. And then you put your demand factor if you need it and get to your appliance total. And then dryer and range, figure out your dryers and the load using the table. Same with range, figure out your range depending on size and number, and use the table for your demand, and then you get your dryer and range total in this column. Last column is heating and cooling, and this is where you take your heating or your cooling and figure out which one you're going to use. And then house loads is the next section. We're not going to deal with house loads in this video. I'm going to do a separate video on house loads, so check the description for a link for that, or go to my channel and find that video. I don't have it done yet, but I will as soon as I can. It's kind of a special deal, so I'm going to treat that separately. And a lot of the apartment buildings and stuff, they won't have house loads. They won't have a separate panel for house loads. So I'm just not going to worry about it in this video. After that, you'll have your largest motor of the building, and we'll talk about that. That takes some special discussion, particularly because of the addition to the Article 220.60 that we have in the 2020 code. But anyway, then you total this up here and get your heating and miscellaneous total. When you're done with that, you total the 4 columns. That gives you your total VA for the building. And then once you have that, you can divide by your volts and whatever phase it is, and you come up with your amps for your whole service. I do have some notes down here listed for the table, but I will just discuss those notes as we come to the specific instances along the way. So we're going to take an example, and then we're going to use this example and plug in our numbers from it into the table so you can see exactly how this works as we go along throughout this calculation. So we got our 5-unit multiplex, Each unit is 800 square foot and has a 1200 watt dishwasher, a 4000 watt water heater, a 1000 watt disposal, 6000 watt range, a 1250 watt clothes washer, a 4600 watt dryer, a 7 kW furnace, and a 3200 watt heat pump. The service from the street is 120 240 volt single phase, and there are no house loads in the building. What is the building total calculated service load in amps? Now this is a very simple, basic calculation that I want to start with just to kind of get you guys' feet wet with this process. All right, well, we're going to start on the far left-hand side, the lighting column, and the first thing we figure up is our square footage per unit, and we multiply that by 3. Why do we do that? 220.14J tells us, under dwelling units, in one family, two family, and multifamily dwellings, the minimum unit load shall be not less than 3 volt amps per square foot. So 3 volt amps for every square foot. That's why you multiply by 3. The lighting and reciprocal outlets specified in 220.14J 1, 2, and 3 are included in the minimum unit load. So this minimum unit load is what we're talking about here. And these are all included, 1, 2, and 3. First one, all general use reciprocal outlets of 20 amps or less, including receptacles connected to the circuits in 210.11C3, which are bath receptacles, and 210.11C4, which are garage receptacles. So those are all included. Also, the reciprocal outlets specified in 210.52E, which are outdoor receptacles, and G, which are basement, garage, and accessory building receptacles, those are also included. And lastly, the lighting outlet specified in 210.70, which are basically all the lighting outlets in your house or in the multifamily dwelling. So all of these are included in this number here. So you don't have to go to anywhere else in the calculation to figure these loads in. They're part of this number. They've already been figured in. In fact, it tells us right here, next sentence, no additional load calculations shall be required for such outlets. So that number here takes care of everything. So we have 800 square foot per unit times 3 is 2400 VA. Now let's go on. It says the minimum lighting load shall be determined using the minimum unit load and the floor area as determined in 220.11 for dwelling occupancies. So it's telling you where to go to figure out how you figure up this square footage. It says 220.11. So down here, 220.11's floor area. The floor area for each floor shall be calculated from the outside dimensions of the building, dwelling unit, or other area involved. For dwelling units, the calculated floor area shall not include open porches, garages, or unused or unfinished spaces not adaptable for future use. So that's pretty straightforward what that's talking about there. It just tells you how to calculate the floor area. Last sentence in this paragraph says motors rated less than 1/8 horsepower and connected to a lighting circuit shall be considered part of the minimum lighting load. So that's the final load that's included in this minimum lighting load. That is 1/8 horsepower motors that are connected to lighting circuits. So you don't have to include those anywhere else in this calculation. All right, and so that takes care of our first step under the lighting column. Next up, we have small appliances. We need a minimum of 2. Now this is per unit. These are all per unit through here. We need a minimum of 2 at 1500 watts each. Well, let's see why. 220.52A tells us that. So 220.52 small appliance and laundry loads for dwelling units. For the small appliance circuit, it says in each dwelling unit, the load shall be calculated at 1500 volt amps for every 2-wire small appliance branch circuit as covered by 210.11C1. Let's see what that says. 210.11C1 says, in addition to the number of branch circuits required by other parts of this section, 2 or more 20 amp small appliance branch circuits shall be provided for all reciprocal outlets specified by 210.52B. So we refer on again to another code article to tell us what specific outlets it's referring to here. Let's go down here real quick and I'll summarize once we're done. 210.52B, small appliances. Reciprocal outlets served. So in kitchen, pantry, breakfast room, dining room, or similar area of a dwelling unit, the 2 or more 20 amp small appliance branch circuits required by 210.11c1, that's those up here, shall serve all wall and floor reciprocal outlets covered by 210.52a, all countertop outlets covered by 210.52c, and reciprocal outlets for refrigeration and equipment. So basically what this means is all the outlets that are in the kitchen, pantry, and any related room to a kitchen, those outlets are going to be figured into these small appliance branch circuits. However, there is an exception, and we'll go over that right now. This exception here says the individual branch circuit permitted by 210.52b1, exception 2, shall be permitted to be excluded from the calculation required by 220.52. Now I don't have that written here, but what 210.52b1 exception 2 says is it allows for other outlets, other reciprocal outlets, to be in that, like the kitchen area say, as long as they are like dedicated or fall under a different circuit that are not for the small appliances. So one example would be like a dedicated microwave circuit that's on like a countertop microwave that sits on the counter. You can have an outlet behind it. That doesn't have to be on a small appliance circuit as long as it's dedicated. Or under cabinet lighting, a lot of under cabinet lighting will plug in to outlets. Those can be off a lighting circuit. Now these receptacles need to be governed by other code articles such as GFCI protection and stuff like that, arc fault and so forth, but they do not need to be calculated into this load here. And that's the point that this exception is making. Next sentence here says where the load is subdivided through 2 or more feeders, the calculated load for each shall include not less than 1500 volt amperes for each 2-wire small appliance branch circuit. All that's saying small appliance circuits so they're coming in on 2 different feeders. So you need to figure 1500 volt amps for each 2-wire circuit. It seems pretty self-evident that you would need to do that, but they're just making it clear. Next sentence, these loads shall be permitted to be included with the general lighting load and subjected to the demand factors provided in table 220.42. Now we will talk about table 220.42 and these demand factors in just a little bit. And we'll come back and I'll remind you of what it says here. But what it's basically saying is these loads here are going to be included in our calculation with our lighting here, our general lighting load. And they'll be subjected to the same demand factors that the lighting does. So knowing that, what we do is we say we need our 2 circuits minimum at 1500 each. That's going to give us 3000 VA here. Now if you have more than 2 small appliance circuits, this may be 4500 if you have 3, or maybe 6000 if you have 4. So just be careful, but it's got to be at least 2. That's a minimum. So you can pretty much count on this number never being less than 3000. Okay, moving on to the laundry. There's a 1 laundry circuit minimum required at 1500 watts each, or 1500 VA each. Let's go to 220.52b this time. Down here under laundry circuit load, a load of not less than 1500 volt amps shall be included for each 2-wire laundry branch circuit installed as covered by 210.11c2. Okay, again, it's referring us up here. Laundry branch circuits. In addition to the number of branch circuits required by other parts of this section, at least 1 additional 20 amp branch circuit shall be provided to supply the laundry reciprocal outlet, or outlets, required by 210.52f. 210.52f simply says, laundry areas. In dwelling units, at least 1 receptacle outlet shall be installed in areas designated for the installation of laundry equipment. So if you have an area designated for laundry equipment, you have to put an outlet there, and then this outlet has to be 20 amps. And then as we keep following this back, so that this is telling us in our load calculation, we have to figure for that required circuit, that required 20 amp circuit, and we have to figure it at 1500 volt amps minimum. Now, back to F here. For multifamily, there are some exceptions. Exception number 1. A receptacle for laundry equipment shall not be required in a dwelling unit of a multifamily building, which is what we're discussing, where laundry facilities are provided on the premises for use by all building occupants. So if there are not laundry provisions in the units themselves, in the dwelling units, then you do not have to have a laundry circuit added here. I have this note 1 here, and I have it written down here. I know it's hidden behind this insert, but it just says that very thing. If you don't have a laundry, you don't need to put this value here. Now let's see the exception 2. It's similar. It says a receptacle for laundry equipment shall not be required in other than one family dwellings where laundry facilities are not to be installed or permitted. So it's basically the same thing. There is some nuances of difference there, but it's saying if it's not a single family dwelling and there are no facilities where laundry is permitted, then you don't have to have a laundry circuit. So summing all that up, it just tells us we have to have a minimum of 1 circuit if we have laundry provisions in the unit. We have to have 1 minimum at $1,500 each, and that gives us $1,500 here because we do have that in our example. So once you have these 3 figures here, you just simply add them up and you get your per unit total, 6,900 VA. Once you have that, multiply all your units. So we have 5 units. We multiply 6,900 by 5, we get 34,500 VA. So that's our subtotal of our building, and that would be called our general lighting load right there for the whole building, our general lighting load. Now that we have the subtotal of our building, our general lighting load, we can apply a demand factor to this, and we'll find out why in 220.40. So 220.40 is where the standard method starts in the code book. This is part 3, feeder and service load calculations. Now this first section here is just a general explanation of what you're doing. So it says the calculated load of a feeder or service shall not be less than the sum of the loads on the branch circuits supplied as determined by part 2 of this article after any applicable demand factors permitted by part 3 or 4 or required by part 5 have been applied. So part 2 is branch circuits, part 3 is this part we're in now, part 4 is optional method, which doesn't apply to us, and part 5 is farm loads, and that also does not apply to us. So basically what it's saying is you're going to add up all of your branch circuits, and that's going to be your total for your general lighting. However, we're going to find out that some demand factors can be applied. But first, we're going to look at this informational note right here. It tells you to go to Annex D, and you'll find some examples of these load calcs. And these can be helpful to some folks. I find them not to be super helpful, or I should say not as helpful as they could be, just because they don't give really any explanation of how they're getting what they're getting. So you kind of have to follow through very carefully to try to figure out how they're getting their answers. And so anyway, go and check those out and see if they're helpful to you. Also, this says see 220.18b for the maximum load in amperes permitted for lighting units operating at less than 100% power factor. So 220.18b just says that if you're using nonlinear lighting like LEDs or fluorescents or HIDs, anything that has like a driver or a ballast, you got to make sure you include those drivers and ballasts in that load. So you got to take all of it. You can't just count up your lamps, your bulbs for your determining your loads. You got to include the ballasts. Okay, going to 220.42, this is general lighting. The demand factor specified in table 220.42 shall apply to that portion of the total branch circuit load calculated for general illumination. So when you see this term demand factor, all it's talking about is that you're taking a portion, like a percentage, of the whole value. So we're not required to use the entire sum of the loads of the branch circuits. We can take this portion of the total branch circuit load as determined by this table over here. We'll go over that in just a sec. Okay, it says they shall not be applied in determining the number of branch circuits for general illumination. So all that means is these demand factors, you can't use those when you're determining the number of branch circuits for your dwelling. You have to take the full number, the full load account when you're determining your branch circuit general illumination. Okay, table 220.42, lighting load demand factors. So you got three columns here. You got your occupancies, your portion of lighting load to which demand factor applies, and your demand factor. Under occupancies, you've got dwelling units, hotels, motels, warehouses, and then anything else. We're just going to be dwelling on dwelling units for this video. And just a note here, this lighting load includes the small appliances and laundry. We talked about that in the last slide. There was a sentence at the end of each of those sections, and it says these loads are permitted to be included in your general lighting, and the demand factors can be applied to them. So I just wrote a little note here in my code book to remind me of that. Okay, so dwelling units, we see that the first 3,000 volt amperes are taken at 100%. So we go over here to our table and it says the first 3,000 at 100%, which means we just take off of this number here, our general lighting load, we take 34,500, subtract 3,000 from that, and just stick that number right there, and that'll be taken at 100%. And that'll leave us with what, 31,500 volt amps. So then it says from 3001 to 120,000 volt amps, you take it 35%. So that's what I have written here. So the next 117,000 is taken at 35%. 35% of that 31,500 is 11,025 volt amps. But what if we had more than that? So what if we had a whole bunch of volt amps? It says the remainder over 120,000, you take it 25%. So that'd be this last line here, the remainder at 25%. You will, during multifamily services, you will end up running into general lighting load of more than 120,000 sometimes, when you get a lot of units. So that's when you would use this. But on a house, single house, you'll hardly ever see this. In fact, you probably never will see any remainder beyond 120,000. So we get our total of 14,025 volt amps for our lighting total, and that takes care of column 1. Next is our appliance column, and these are fixed appliances, so we're not talking curling irons and waffle irons and blenders, stuff like that. We're talking things that are fixed in place, like perhaps dishwasher, disposal, that type of thing. And 220.53 covers these types of loads. It says appliance load for dwelling units. It shall be permissible to apply a demand factor of 75% to the nameplate rating load of 4 or more appliances rated 1/4 horsepower or greater, or 500 watts or greater, that are fastened in place and that are served by the same feeder or service in a 1-family, 2-family, or multifamily dwelling. This demand factor shall not apply to household electric cooking equipment that is fastened in place, clothes dryers, space heating equipment, and air conditioning equipment. So these are normally thought of as appliances, and they are, but in this case, they are not including them in this load because all 4 of these have their own special treatment, as we'll see in just a moment. So as you see over here, this does not include cooking, dryers, heat, and AC. I've got a note here. And then, as it says here, this is only for appliances rated 1/4 horsepower or greater, or 500 watts or greater. So anything less than 1/4 horse and 500 watts must be taken at 100% no matter what. Now that may be like a hood fan. Those generally are less than 500 watts, the smaller ones, and 1/4 horse. Now if you have 4 or more, it says you can take 75% of that value. So you list out your appliances here, and you'd put their VA, their nameplate wattage here, and then if there's more than 4, you just add them up, take 75%, and that's your total. If you have 3 or less, you add them up and take 100%, and that's your total. But don't forget, if you have anything that is less than 1/4 horse and less than 500 watts, you must take those at 100%, even if you have 30 of them. You still got to take them at full value. So let's go ahead and plug in our numbers and see how this plays out. We've got our appliances listed here. We've got dishwasher, water heater, disposal, and their values listed over here. We're going to add those together. We get our subtotal per unit. Remember, this is per unit, and we get 6,200 VA per unit. Once we have that, we can multiply by the number of units. We have 5, so 6,200 times 5 is 31,000 VA. That is our subtotal of the building. Now, remember, if we have 4 or more appliances right here, we get to take the demand factor of 75% of this value. Now, this is 4 or more of the feeder or service of the one family, two family, or multifamily dwelling, not each unit. So in a multifamily, you are almost always going to have more than 3 appliances because you've got at least 1 or 2, or in this case 3, in each unit. So remember, that demand factor and that limitation on the demand factor applies to the entire service, the whole building. So in multifamily, you're pretty much going to automatically be using a 75% demand factor of your subtotal building for appliance load. Well, that gives us an appliance total of 23,250, 75% of 31,000. Okay, moving on to the dryer and range column. We'll take the dryer first. We've got Article 220.54 discusses electric clothes dryers for dwelling units. It says the load for household electric clothes dryers in a dwelling unit or units shall be either 5,000 watts or VA or the nameplate rating, whichever is larger, for each dryer served. Okay, that seems pretty straightforward. So we take a minimum of 5,000. So no matter what, we're going to have 5,000 here minimum. However, if the nameplate is above 5,000, we've got to put the nameplate value. In our case, ours are all under 5,000, so we're going to use a minimum of 5,000. So that is per unit. Once we have that, we are going to multiply by the number of units we have. So we know we have 5 units times 5,000 is 25,000 VA. But we get to take a demand percentage of this. It says right here, next sentence, the use of the demand factors in table 220.54 shall be permitted. All right, let's go down to 220.54. Demand factors for household electric clothes dryers. So you have your number of dryers over here and your demand factor over here. So once you get above 4 dryers, you can start using these demand factors. Anything 1 through 4 is 100%. But once you get to 5, which we happen to have 5, we have 5 units, so our demand factor is 85%. And here it is. Demand percentage of the table is 85%. So we take 85% of that 25,000 and it gives us a building dryer total of 21,250 VA. Okay, so for our application in this example, we're done. But suppose you had a 3-phase service that was feeding your building. These are single-phase dryers, and if you had a 3-phase service, you'd have to calculate it a little bit differently. Let's look at this next sentence here. It says, where 2 or more single-phase dryers are supplied by a 3-phase 4-wire feeder or service, the total load shall be calculated on the basis of twice the maximum number connected between any 2 phases. And then they make a note here that says kVA and kW will be considered equivalent for these loads calculated in this section. They do the same thing with the range. We'll see that later. But anyway, back to this. So if you have a 3-phase service feeding this building, we have to do it a little bit differently. And so I've created a formula that will take care of this for us. If we look at this box right here, I have single-phase dryers on a 3-phase service. And it references 220.54. So what you're going to do is you're just going to take this as it is. You would take your number of dryers, you're going to divide by 3, you're going to round up your answer, and then multiply by 2. That's going to give you your new number of dryers. Once you have that new number, you apply that number to table 220.54 over here. And then you'll come up with an answer in watts once you apply the demand factor. And once you have that answer in watts, you multiply by 1.5, and that'll give you your total demand. Now, it would take a while to explain exactly why this formula works the way it does. I'm not going to do that in this particular video. But if you have questions on that, if you need some understanding on that, put some comments in the comment section below, and maybe I can make up a video explaining exactly how I come up with this formula. But at least you have it there and you can play around with it if you'd like. Okay, so that takes care of our building dryer total in VA. Next, we're going to move on to the range. So Article 220.55 tells us electric cooking appliances in dwelling units and household cooking appliances used in instructional programs. So we're going to be dealing with dwelling units. It says the load for household electric ranges, wall-mounted ovens, counter-mounted cooking units, and other household cooking appliances individually rated in excess of 1 3/4 kW shall be permitted to be calculated in accordance with Table 220.55. And here's that same note we saw for the dryers. kVA shall be considered equivalent to kW for loads calculated under this section. Over here, Table 220.55, it tells us we can use the demand factors in this table. Let's read it. It says demand factors and loads for household electric ranges, wall-mounted ovens, counter-mounted cooking units, and other household cooking appliances over 1 3/4 kW rating. Then it has a little parenthetical statement here, column C, to be used in all cases except as otherwise permitted in note 3. We'll come back to that in a sec. So this table, the range table, is very confusing for a lot of folks, especially those folks that are new to the industry or new to the code book. It looks complicated, and it is a little complex, but it's not as difficult as it may seem to figure out once you see what their intent is, once you see where they're going and what the process they're using is to reach their values, and we'll go through that. First off, I want you to notice that I have boxed in an area here. We have 3 columns. We have column A, B, and C, and I've boxed in A and B because they are treated separately than column C. And the biggest way is these are all percent values. These are percentages. That's why I highlighted this in orange to remind me that this is percent. Column C, however, is a kW value. And so I've given myself a little note to remind me it's kW. This could be very destructive to a calculation if you get these mixed up. Say you had 20 units and you come down here and let's say it's 8,000 kW range you're using. And so it fits column B, or you can use column C. You're going to come up with 28 and you're going to say, oh, 28 kW, no problem. But that'd be wrong because it's actually 28%, and that could be way off of what you should be getting. Or you might come over here and you say, oh, 35%, and you take 35% of your value and you'd get it way wrong because it's actually 35 kW. So that's very dangerous to get these mixed up. So that's the first thing to notice. The easiest way to use this table is this parenthetical statement here. It says column C is to be used in all cases except as otherwise permitted in note 3. So what they're saying is you can use column C for any range you have or any cooking appliance you have that's not over 12 kW rating. And that's the easiest way to use this table, because then all you do is if you have one appliance, your value is going to be 8,000 watts, 8 kilowatts. Whether the nameplate rating says 3,000 or whether it says 11,000, your value is going to be 8,000 watts. If you have 2, it's going to be 11,000. If you have 3, it's going to be 14,000 watts. And so it's as simple as that, really easy. However, by using this column, you are building in a little cushion, generally speaking, and you could shave some of that off by using A or B if your range fits in these categories here. But only as note 3 allows, just like this says up here, otherwise permitted in note 3. Let's go down and see what note 3 says. It says over 1 3/4 kW through 8 3/4 kW. All right. In lieu of the method provided in column C, it shall be permissible to add the nameplate ratings of all household cooking appliances rated more than 1 3/4 kW, but not more than 8 3/4 kW, and multiply the sum by the demand factor specified in column A or column B for the given number of appliances. Where the rating of cooking appliances falls under both column A and column B, the demand factors for each column shall be applied to the appliances for that column and the results added together. Okay, That's pretty wordy, but all it really is saying is if you have a cooking appliance that falls into this category, say column A, it's less than 3.5 kW rating. Well, hold on. Before I go further, I've got to make a note here. This says less than 3.5 kW, but what it really should say is between 1 3/4 kW rating and 3.5 kW rating. The reason for that is this table doesn't apply to anything under 1 3/4 kW. So it's a little misleading to say less than 3.5 instead of saying between 1 3/4 and 3.5, which is what I think it should really say. But anyway, if you have an appliance that falls under column A, then you can use column A. If you have an appliance that falls under column B, you can use column B if you want to. But it's got to fit those criteria right there. Now, the second part of that says if you have multiples and they fall in both categories, like let's say you have 2 appliances that fall under column A and 2 that fall under column B, then you will use 75% demand factor for the 2 in column A, 65% demand factor for the 2 in column B, and then you add the 2 values together to get your total kilowatt rating. So it's really pretty simple and intuitive, really. Now, if you're taking a test and they're asking you for the minimum for a particular range calculation, you're going to need to use column A or column B if your range or your cooking appliance happens to fall in these categories, because that will most likely almost always be the lesser value. If you just go to column C every time, your value is generally going to be a little high. You know, you'll have a little cushion built in, which isn't a big deal. It's actually a good idea for a real-world situation. But if you're answering a question on a test and they want the minimum, you're going to need to go to column A or B in some situations. Okay, so what if you have a cooking appliance that is less than 1 3/4? Well, it doesn't say explicitly, but the implication is that anything that's not covered by this table, you just take it 100%. That would also be the case if you had something over 12 kW, because this says not over 12, so that's kind of your ceiling. However, there are some notes that cover things that are over 12. Notes 1 and 2. Let's check those out. Over 12 kW through 27 kW ranges, all of the same rating. So if you have multiple ranges, all of the same rating, then you can use this if they're between 12 and 27 kW. It says, for ranges individually rated more than 12 kW, but not more than 27 kW, the maximum demand in column C shall be increased 5% for each additional kilowatt of rating or major fraction thereof, by which the rating of individual ranges exceeds 12 kW. Okay, that seems kind of complicated, and it is a little bit. It takes a little bit to figure that out, but what I did was I drew up a formula to make this much easier, and this is the formula right here. If you plug in this formula and put your numbers, whatever your kW rating for your range is, into this formula, you'll get the right answer every time. You'll get the right value of your total demand. And let me be honest, it took me a little while to figure this up. In fact, you can see over here, this is my long version of the formula, but then I was able to simplify it into this mode here, so it's much cleaner. But if you just plug your values into there, so your column C value plus your column C value times the kilowatt value minus 12, and then times 0.05, that'll give you your total demand if you have ranges that are all the same rating. Okay, so what if they're not the same rating? Well, let's go down to note 2. Over 8 3/4 kW through 27 kW ranges of unequal ratings. Okay, for ranges individually rated more than 8 3/4 kW and of different ratings, but none exceeding 27 kW, an average value of ratings shall be calculated by adding together the ratings of all ranges to obtain the total connected load, using 12 kW for any range rated less than 12 kW, and dividing by the total number of ranges. Okay, we'll stop right there for a sec. All that's saying is you're averaging. You're taking the averages. So again, I have another formula down here, or instructions, for number 2, and it says average all your range kWs But you got to make sure that any kW that's under 12 kW, that you use 12 kW as the value. So you can't use any values less than 12 kW. Anything below that, just automatically it's used as 12 kW. So once you average all your ranges together, keeping the 12 kW minimum in mind, then you just use the formula for note 1, which is this formula. And that's what this last sentence says. It says, then the maximum demand in column C shall be increased by 5%, or increased 5% for each kilowatt or major fraction thereof, by which this average value exceeds 12 kW. All right, so that's the same sentence as this one up here, pretty much. And that's the same formula. I know that seems complex and confusing, but if you read through it a couple times, maybe back this up and listen to it a few times, it should start to make sense to you, and you'll start to see why this formula actually does exactly what the words are telling us to do. Okay, so just a quick recap. So the easiest way to use this table is go to column C. Most cooking appliances are going to fall in this category. They'll be under 12 kW. Not all, there are some larger than that, but most of them are under 12 kW, and so you can use column C very easily. So whatever number of appliances you have, if you have 17, you'll have 32 kW. If you have 25, you'll have 40 kW. If you're going to try to get away with less, a lower value, then you can use column A or column B if your appliance falls in their respective categories here. So if you have a 6,000 kW range, let's say you have 19 of them, go down here, 19, 6,000, multiply 19 by 6,000 to get your total demand, and then you take 28% of that number. And that'll be your total demand. All right, so it's pretty simple, really, the whole table, once you break it down. Okay, now let's go on to the next paragraph here. It says, where 2 or more single-phase ranges are supplied by a 3-phase, 4-wire feeder or service, the total load shall be calculated on the basis of twice the maximum number connected between any 2 phases. Okay, so we have a table here that gives us a couple of equations, some calculations that we do for this. This is very similar to the 3-phase dryer feeder that we were talking about. We do the same thing for the range, only there's a little bit of a difference because of when you get over 12 kW. And if you remember, this column C says not over 12 kW, but then we have notes 1 and 2 that tell us what to do if it goes over 12 kW, and that's what this right column is for. But if you're under 12 kW, you'd be using this left column. So right here we got single phase ranges on a 3-phase service. The reference is 220.55. And ranges less than or equal to 12 kW, like T 220.55 tells us. You take your number of ranges, divide by 3, round up your answer, and then multiply by 2. That gives you your new number of ranges. So just like dryers. So now you take that new number of ranges and you plug that in to the table, and you get your column C value. So you get your column C value and you multiply that by 1.5, and that gives you your total demand. That's for ranges less than or equal to 12 kW. I put a little red note here just as a reminder that you're using your new number of ranges here. Same with this side over here. So that one's pretty straightforward. Now this side, this is ranges greater than 12 kW, and this is referencing notes 1 and 2 from table 220.55. You take your number of ranges, divide by 3, round up your answer, and then multiply by 2. That gives you your new number of ranges. So same exact steps. But now it changes, because now you got to use that other formula. So you take your new number of ranges, plug it into the table, get your new column C value, and you put that value here, and you're going to add it to all of this once you multiply this together. So you're going to take that same value times your kilowatt rating minus 12 and multiply that by 0.05. Once you do that, you add it to this column C value, and you'll get an answer in watts. Multiply that answer by 1.5, and that'll give you your total demand. Again, I'm not going to go into an explanation on how this works right now, but I can do that in a different video if you guys want. But you should be able to just plug your numbers into this and come out with the right answer every time without any trouble. And that's going to come into play on multifamily, fairly often, at least in my experience. A lot of multifamily it's in the city usually, and so they have three-phase power available, and it's more efficient to run it on three-phase. So likely you'll run into this quite often on multifamily. Maybe not the smaller stuff like duplexes, triplexes, stuff like that, but once you get into larger ones, apartments and some condos and things like that, you'll be running into three-phase services. The last thing this says here is informational note number 1, see examples in informative Annex D. So you can go to Annex D and find examples of range calculations. And then it makes a note that for commercial cooking equipment, see table 220.56. And I'll be going over that in my commercial calcs. And so we're not going to talk about that now. Okay, so what have we learned? We've got our 6,000 watts for each range. So each unit has 6,000 watts for the range. We have 5 units, so we multiply 5 by 6,000, we get 30,000. So since there's 6,000 each, we can use column B because that falls between 3.5 kW and 8.75 kW. If we go down to 5 ranges, come across, and our demand factor, or our percentage, is 45%. That's our demand factor percent. So down here, we got 30,000 at 45%. We come up with 13,500 volt amps. So then we take our dryer total and our range total, and we come up with 37,750. Our dryer and range total for the building is 37,750 VA. Okay, last column. This is heating, cooling, and some miscellaneous loads. We'll start with the heating. If we go over to 220.51, we got fixed electric space heating. Now this is any kind of heating that's fixed. So this includes a furnace or a baseboard, ceiling heat, or wall heat, any of those. Now it says fixed electric space heating loads shall be calculated at 100% of the total connected load. However, in no case shall a feeder or service load current rating be less than the rating of the largest branch circuit supplied. Okay, so that's just simply saying, that second sentence, that your service can't be smaller than your largest branch circuit, which seems pretty straightforward or pretty obvious, I guess, but I guess they had to put that in there, so there must be a situation where that would come into play. But anyway, we got to take our fixed electric space heating loads at 100% of the total connected loads. So here we got all heaters at 100%. So that's 7,000 per heater times 5 is 35,000. Okay, and then we have an exception here. It says where reduced loading of the conductors results from units operating on duty cycle intermittently or from all units not operating at the same time, the authority having jurisdiction may grant permission for feeder and surface conductors to have an ampacity less than 100%, provided the conductors have an ampacity for the load so determined. I really don't think this should be an exception. I think it should be maybe an informational note at best. And the reason for that is it says the authority having jurisdiction may grant permission. And that can apply to any code at any time. So I don't know why they put it here, why they thought it necessary to write this exception, because the authority having jurisdiction has total control and authority. They can take whatever parts of the code they want or reject whatever parts they want. They can reject the whole code and not even adopt the 2020 NEC. So it really doesn't make sense to me why they put this here. So I think you just don't need to worry about this at all. Okay, so our next line here is cooling. So like heat pumps or air conditioners. Now there's nothing specific in Article 220 that tells us to put an AC or where to put the cooling. All we know is from Article 220.40, if you remember back, it tells us that our feeder or service load calcs are dependent upon all the branch circuits and adding them all up, right? Except for when we can apply demand factors. And so this would be included in that. It's one of the loads from our branch circuit. It's a branch circuit load. So we have to include it somewhere. But we can't include it in the appliances because as we saw there's a special note that says this does not include air conditioners and heaters and so forth, a few loads. So we have to put it somewhere. So I believe this is the best place to put the cooling, and I'll explain why in just a minute. But we have 3,200 watt heat pumps and 5 of them. So 3,200 times 5 is 16,000 watts or VAs. Okay, we got to go to 220.60, right over here, non-coincident loads. Where it is unlikely that 2 or more non-coincident loads will be in use simultaneously, it shall be permissible to use only the largest load or loads that will be used at one time for calculating the total load of a feeder or service. Okay, we'll stop right there. We won't take this next sentence yet. All right, so what that tells us is if you have 2 loads that are non-coincident, so they won't operate or are unlikely to operate at the same time, then you only need to take the larger of the 2. So that's why I think the heat pump or the AC should go in this place, because then we can compare it to the heater. Typically speaking, a heater will not be used the same time as an AC. Now it can be, so you got to be careful on what it is. If you have wall heaters, say, and then you have an air conditioner, well, they can very easily be used simultaneously, but it just says where it is unlikely that the 2 will be used simultaneously. So that is still an unlikely scenario that you'd be heating one room and cooling another, but you could. Now on a more conventional forced air system where you have an actual furnace, air handler, and a heat pump, then it's much more unlikely that the 2 could run at the same time. There'd almost have to be a problem for that to happen. So that would definitely fall under this category, and you would just take the larger of the 2 loads. So in this case, the heater is the larger load, and so we take the heaters, multiply by 5, and we get 35,000, and we take that at 100% right there. So this figure does not factor into the equation at all. Okay, now we're going to take a slight tangent for a moment. We'll come back to this section over here, this last sentence of 220.60. If we go to 220.50 under motors, it says motor loads shall be calculated in accordance with 430.24, 430.25, and 430.26, and with 440.6 for hermetic refrigerant motor compressors. Now what we find there in 430, 24, and 25 especially is that if you have multiple motors in a building, in this case, you need to take the largest motor and add an extra 25% of it to that load. So what we have always done in the past is, since the air conditioner, or heat pump in this case, has been ixnayed from the calculation, we'd go through and find another largest motor, because normally the AC is going to be the largest motor. But we'd go through and find another one because that has been trumped by the heater load. So we'd go find like a disposal or something like that for our largest motor. And then we take 25% of it and add it to it and factor it in to our calculation. That's how we've done it. Well, in the 27 years I've been doing this, that's how we've always done it. But now in the 2020 code, we have a little bit of a conundrum, I'll call it. They have added a last sentence here to 220.60 under non-coincident loads. Let's read that now. It says, where a motor is part of the non-coincident load and is not the largest of the non-coincident loads, 125% of the motor load shall be used in the calculation if it is the largest motor. Okay, so we have 2 ideas going on here. We have the non-coincident loads idea and we have the largest motor idea. Now, they're not always related to each other, but they can be. In this case, and in most houses or multifamily dwellings, they will be related, because your non-coincident loads in this case are going to be your heat and your cooling. And then your largest motor is also going to be your cooling, typically. So this does apply. It says where a motor is part of the non-coincident load and is not the largest of the non-coincident loads. Well, that's our situation. The AC, or the heat pump, is part of the non-coincident loads, but it is the smaller of the 2. That's what this is saying. So it says, if that's the case, 125% of the motor load shall be used in the calculation if it is the largest motor. And it is the largest motor in our case. So they want us to use 125% of this motor load. Now here is where I think there is a discrepancy between the language of this section and the intent. If we take this at face value and take 125% of this load, now remember this is just going to be of one of these units, the largest motor in the building. So we take 125% of 3200, which is the largest motor. It's just one heat pump. So 125% of that is 4,000. So if we took this at face value, you'd have to add 4,000 to the 35,000. So that'd be 39,000 VA just for heating and cooling, and largest motor, heating and largest motor. I don't personally think that's what their intent was. I think their intent was probably to capture that extra 25% of the largest motor in the building, because they know that it's possibly been eliminated from the calculation, but it's still a load on the service. So they want to capture that. And again, this is my interpretation of it. And so I think what this should have said is, instead of 125%, it should have said 25%, and that would make more sense. Then we're taking the largest motor and an extra 25% of that motor and adding it to our equation. Therefore, that's how I have done it here in this calculation. So in figuring the largest motor of the building, we've taken one of the heat pumps, which is 3,200. We've taken 25% of that, which is 800, and we've added it to our 35,000. And that gives us 35,800 for our heating and miscellaneous total. Now, if you need more explanation on that, if you'd like more clarity on that, because I know that's kind of confusing, just let me know in the comments. And again, I can make up a video that just discusses this 220.60 here. But again, there's been a lot of dispute and argumentation over this among experts since this came out, because nobody really understands what their intent was. I have an email into the NFPA, and I haven't gotten a response, and I really don't expect one. But I've read a lot of forums, and there's a lot of confusion because of this sentence. Now, the funny thing is, in the 2023 code, which just came out in January, they have amended this sentence, and the problem is they haven't made it any clearer. It's actually more confusing than this one is. So now we're going to have a whole nother code cycle of a lot of disputing and arguments and just confusion over what the intent is. So that'll be interesting. But anyway, that gives us our heating and miscellaneous total. One thing we did skip over was this section right here for house loads. If it applies. So if you have house loads, you know, like if you have a lobby area or maybe a community laundry facility or whatever it may be, you need to put those loads in here as well. Now in our case, there are no house loads as it's showed in the example, so we don't have to worry about it. But if you do have house loads, you got to add them all up. You got to treat them almost like they're their own calculation in and of themselves, because you could have restaurants, you could have kitchens, you could have all kinds of stuff. Elevators, lobbies, laundry facilities. There's a lot of different things that can apply here. So you got to figure those up separately, and then you would plug your number in right here once you have those totaled up, and that would become part of this miscellaneous total here. But as far as house loads go, I'll have those figured up on a different video. So please check that out on my channel if you're interested. All right, so we get our total here, 35,800. Okay, now, so here is the whole template. Actually, this is the whole worksheet filled out for you to see all in one place. We've got all our values plugged in here. You got your column totals for your lighting, appliances, dryer and range, and heat and miscellaneous. Now we just add these four columns together. We get our 4-column total VA, and this is your building total VA, 110,825. Once we have that, We can divide by 240 single phase because that is our example over here, 240 single phase. And we come up with 462 amps. So now we can size our feeders, our conduit, our meter packs, go from there. So here is a template one more time, and I took most of the color out of it so it's easier for you to maybe take a screenshot and you can print it up. You can use it as a worksheet. You can use it to study off of or to use in a real world situation, because this can be used for any multifamily dwelling for the standard method. Real quickly, I'll go over the notes down here. So note number 1 was up here for laundry and also over here for dryers. It says exclude this value if no laundry provisions exist in individual units. So on a multifamily, sometimes there is no laundry provisions at all, so you don't have to figure those in. You can just leave those blank. Number 2 over here, 220.60, we just talked about that. It's disputed. The wording seems not to reflect the intent, so you got to check with your local inspection agency for their interpretation. Note 3 is the house loads. House loads are covered in another video, and I'll put a link in the description when I get that video made. And then number 4 is the largest motor, and on a state exam, you're only going to account for this extra 25% if they provide you the info. They're going to tell you what the largest motor is and what that value is, and then you'll have to take an extra 25% of it. But they don't expect you to go trying to guess what the largest motor is in their example they're using. So don't worry about that. If they don't give you the info, then you don't add it in your calculation. So that's just something good to know for a test. Well, hey, I really appreciate you watching. If you found this video helpful, please like and subscribe to my channel. That will help the YouTube algorithm push this out so more people can find it. I'm sure there's a lot of people out there that are looking for help on these calculations, and I'm just trying to kind of give back a little bit because I've received a lot of help over the years myself. Feel free to check out my channel. I'll be continuing to post videos like this as frequently as I can. But let me know what else you'd like to see, anything else electrical related, and I'll see if I can't make up a video for that. And just remember, stay free.